High above the blistering Mojave Desert, the largest operational aircraft in the world, with a jaw-dropping wingspan of 385 feet, thundered up to the skies on a mission of paramount importance. Yet, even more critical than the rock's colossal frame was its cargo. Clamped beneath its massive structure was the Stratolaunch's TA-1 hypersonic test vehicle, a cutting-edge powerhouse poised to redefine the future of American hypersonic technology. For years, the corridors of the Pentagon have buzzed with anxiety. Intelligence reports painted a grim picture. Russia and China potentially outpacing the United States in the hypersonic arms race. Claims surfaced of enemy hypersonic nuclear missiles that could strike with such unfathomable speed that they'd be untouchable by any current American defense system. In the shadow of these chilling assessments, the U.S. military has placed its bets on the Stratolaunch's TA-1. This moment is not just another test flight. It's America's audacious punch back in the face of escalating threats. With top military brass locked in, the inaugural hypersonic flight of the TA-1 may very well be the key to America's military supremacy in the near future. The concern over a potential hypersonic gap between the United States and its geopolitical rivals, Russia and China, has been voiced by several American military experts, politicians, and military officers. This apprehension stems from the perceived advancements in hypersonic technology by Russia and China compared to the U.S., which many agree seems to be lagging behind when it comes to hypersonic military solutions. Russia has publicized its development of hypersonic weapons, like the Avangard and the Kinzhal. The Avangard is claimed to be capable of reaching speeds above Mach 20, and President Vladimir Putin has touted it as capable of evading American missile defenses. Similarly, China has conducted tests of hypersonic glide vehicles, and in 2021, it reportedly tested a nuclear-capable hypersonic missile that orbited the globe before speeding towards its target, demonstrating advanced maneuvering capabilities that could challenge existing missile defenses. The claims made by Russia and China about their hypersonic prowess are difficult to verify independently. Most information comes from state-controlled sources, which could potentially exaggerate the facts for strategic posturing. However, the tests they have publicized and the reactions from the U.S. military and intelligence communities indicate that these weapons are indeed a significant concern and likely possess some of the claimed capabilities. The U.S. has not publicized possessing weapons with similar features. Several factors contribute to why America might have lagged in hypersonic technology. Initially, the U.S. focused more on other technological areas, like stealth and precision-guided munitions. Furthermore, budget constraints, shifting priorities over the past 2 decades, and technical challenges inherent in hypersonic development, such as material science and propulsion technology, have impacted progress. The potential hypersonic gap presents a grim scenario for U.S. military strategy. Hypersonic weapons can travel with speed and maneuverability that render traditional missile defense systems virtually useless. This could theoretically give adversaries like Russia and China a significant strategic advantage in a conflict, potentially undermining the deterrence that the U.S. relies on. In response to these developments, the U.S. has ramped up its own hypersonic programs. The Defense Department has requested substantial increases in hypersonic research and development. For instance, the fiscal year 2022 budget request included $3.8 billion for hypersonic research, a significant increase from previous years. The U.S. military is developing multiple hypersonic systems, such as the Air-Launched Rapid Response Weapon and the HAWK, short for Hypersonic Air-Breathing Weapon concept. Additionally, the Pentagon is investing in private hypersonic projects that might help the military collect critical data about hypersonic travel. One of those projects is Stratolaunch's TA-1 hypersonic test vehicle. In a historic first for aviation, the air-launched Titan Stratolaunch, birthed by the visionary mind of the late Microsoft co-founder Paul Allen, unleashed a significant breakthrough. Its behemoth rocket airplane, boasting a wingspan of 385 feet, successfully launched a wing test vehicle on its inaugural rocket-powered ascent. Stratolaunch's single-use TA-1 test vehicle blazed a path toward the development of future reusable hypersonic test vehicles, crucial for propelling the U.S. military to new heights in aerial combat. According to Stratolaunch's president and CEO, Zachary Krever, the TA-1 roared into supersonic speeds, flirting with the hypersonic threshold of Mach 5. Krever stated post-flight, quote, "While I can't share the specific altitude and speed TA-1 reached due to proprietary agreements with our customers, we are pleased to share that, in addition to meeting all primary and customer objectives of the flight, we reached high supersonic speeds, approaching Mach 5, and collected a great amount of data at an incredible value to our customers. This landmark test was conducted above the Mojave Air and Spaceport, the home base of the Rock, the world's largest operational aircraft. Designed as a colossal flying launch pad, the Rock is engineered to deploy rocket-powered vehicles like the TA-1 and its successors. The air launch method allows these significant missions to originate from virtually any airport equipped to handle Rock's massive frame. This concept isn't new. It echoes the 2004 launch strategy that clinched the $10 million Ansari X Prize for private spaceflight, with Paul Allen's backing. Founded in 2011 by Allen, Stratolaunch initially aimed to dispatch crewed spaceplanes into orbit. However, following Allen's passing in 2018, ownership switched to Cerberus Capital Management, who relocated the company's headquarters from Seattle to Mojave and pivoted towards advancing hypersonic technology. Rock's maiden test flight was in 2019, and since then, Stratolaunch has been methodically gearing up for this groundbreaking powered flight. The standard mission profile involves carrying the test vehicle beneath the Rock from takeoff, and then releasing it at an altitude exceeding 20,000 feet for its fiery journey through the skies. For the U.S. military, this first flight of the TA-1 is a pivotal moment in its path toward developing advanced hypersonic technology and closing any possible gap that might exist between the U.S. and its superpower rivals across the globe. The Stratolaunch's TA-1 hypersonic test vehicle helps the U.S. Air Force Research Laboratory, or AFRI, by providing a platform to conduct various flight profiles that simulate hypersonic flight conditions. This allows the military to develop and validate hypersonic weapon systems and their countermeasures. The TA-1 vehicle serves as a crucial step toward reusable hypersonic vehicles. Its design allows for carrying out high-speed tests at speeds of Mach 5, offering a rapid, cost-effective, and repeatable testing method. That is the critical difference and what makes the Stratolaunch project so valuable. Each flight attempt might cost several millions of dollars when testing their own hypersonic missile prototypes, and the technology can be lost during the trial. On the other hand, by using a reusable system such as the TA-1, the U.S. military can drastically reduce costs and continue to gather critical data and test internal systems. These tests are essential for refining the technology necessary for future operational hypersonic systems, which are crucial for national defense, given the advanced hypersonic capabilities of other nations like Russia and China. Stratolaunch has contracts with the U.S. military, including a Navy-backed contract for multiple hypersonic flight tests, which supports the development of the Multi-Service Advanced Capability Hypersonic Testbed, or MUX-TB. This program is designed to accelerate the testing and advancement of commercially available hypersonic systems, enhancing the Defense Department's ability to field these advanced technologies. In addition to providing a platform for these tests, the data and insights gained from the TA-1 flights are invaluable for improving operational strategies and technological frameworks within the hypersonic domain, further underlining the strategic importance of such test vehicles in national defense technology development. Although the TA-1 test flight did not hit Mach 5 speeds, and thus did not officially reach hypersonic status, it signaled a significant leap toward the operational goals of the program. The flight also debuted the in-flight performance of the Ursa Major's Hadley rocket engine, an experimental powerhouse designed for space launch vehicles, named after the Hadley Rifle, the lunar geological formation explored by the Apollo 15 crew. The main objectives were clear: execute a safe release of TA-1, ignite the engine, achieve a steady climb in altitude, and ensure a controlled splashdown in the Pacific Ocean. This test is a cornerstone for the development of TA-2, aimed to be Stratolaunch's first fully reusable hypersonic vehicle, a game-changer poised to narrow the American gap in hypersonic technologies. Stratolaunch President and CEO Crever expressed his forward-looking perspective, quote, "Our goal with this flight was to continue our risk reduction approach for the TA-2's first reusable flight. We are excited to review the data from today's test and use it to inform our next steps toward TA-2's maiden flight later this year." The U.S. military plans to harness data from Stratolaunch's flight tests to advance hypersonic weapon systems and countermeasures in response to adversaries' swift development of similar technologies. Russia, for example, has already employed air-launched hypersonic Kinzhal missiles in its conflict with Ukraine. Despite early reports questioning the weapon's effectiveness, it remains significantly more advanced than American capabilities in the realm of hypersonic missiles. As Stratolaunch propels forward, work is underway on TA-3, the next fully reusable hypersonic vehicle in its Talon A lineup. Additionally, the company has commenced modifications on the Spirit of Mojave, a converted Boeing 747-400 acquired from Virgin Orbit during its bankruptcy. This aircraft is set to become Stratolaunch's second air launch platform, supplementing the Colossal Rock. Stratolaunch's journey through the development of hypersonic technologies marks a pivotal chapter in American aviation and military prowess. Though the TA-1 did not reach hypersonic speeds, its successful test flights and the introduction of the powerful Hadley rocket engine demonstrate significant strides towards operational readiness and technological advancement. With each test, Stratolaunch not only hones its craft, but also contributes vital data to the U.S. military's ongoing efforts to match and surpass global competitors in hypersonic warfare.